The last item of lesson 10.4 that we're going to look at is the idea of compliments. Now, this isn't a compliment that you might receive from your boyfriend or girlfriend telling you, "Oh, you look so nice today. Oh, I like how that shirt brings out the color of your eyes." It's not like that at all, actually. It's a compliment, and it's even spelled differently. So compliment, like I was just teasing you about, would be compliment spelled with an I here. Compliment in math is C-O-M-P-L-E-M-E-N-T-S. So let's look at this. Compliments. The event A bar, so capital A with a bar on the top of it, is called the complement of event A. And it consists of all outcomes that are not in A. So everything that's not what we would like. And the notation A bar is read, as I've said it a couple times, A bar. Now, the probability of the complement of an event. The probability of the complement of A is the probability of A bar, and it's equal to 1 minus the probability of A, the actual event happening. So all probabilities, if I had the probability of flipping a coin and getting heads, well, that probability would be 1 out of 2. The probability of not getting heads, well, that'd be the complement. That's also 1 out of 2. So when you add those two things together, you end up with 1. You can think of it sort of with a complementary angle, something you learned about in geometry. It's the same idea. They're going to add up to a particular total. In this case, my probabilities will always have to add up to 1. So, putting this to work for us, a card is randomly selected from a standard deck of 52 cards. Find the probability of each event. So our first probability is find the probability that the card we're selecting is not a 7. So the probability that our card is not a 7. So I would say that the probability, so event A would be the probability that it is a 7. So if I wanted the probability that it's not a 7, I take 1 minus the probability of event A occurring. Well, what's the probability of actually drawing a 7? Well, let's see. There's 4 7s in the deck, and there's 52 cards in the deck. So, or I suppose I could have that rewritten as 1 out of 13 as well. We can reduce that. Either way, when I subtract to find the probability that the card is not a 7, 1 minus 4 over 52, 1 being 52 over 52, minus 4 over 52 would be 48 over 52. And I could reduce that to 12 out of 13. So there would be the probability of drawing a card that's not a 7. Complement to drawing a 7. Now, how about the card is not a red face card? Well, in this case, the event A would be that it is a red face card. So if I want the probability of the complement not getting a red face card, I take 1 minus. Let's see, there's 3 face cards with hearts, 3 face cards with diamonds, so there's 6 face cards that are red out of the 52 possible cards in our deck. When I take 1 minus 6 out of 52, let's see, again I have 52 out of 52. 52 minus 6 is 46 out of 52. And then when I reduce 46 out of 52, I could get 23 out of 26. Now for either of these, a decimal would be just fine as well if you prefer to have it in decimal form. And those are, when we run into using complements, these are pretty simple examples that you could probably just figure out how many not red face cards there are, or how many cards that aren't 7s, and work it that way. But as we get into some more complicated situations, using a complement actually becomes quite helpful in finding different probabilities. And that is it for lesson 4.